This week in the Forces and Motion topic, we'll be looking at mass and weight. So the objectives for the lesson: define weight, recall and use the equation that weight, which is a force measured in newtons, is equal to the mass of an object, which is the amount of stuff the object's made of, which is measured in kilograms, multiplied by the gravitational field strength. This is the size of the pull per unit mass, and on Earth that is 10 newtons per kilogram. That's the unit for gravitational field strength. Often referred to as just gravity. And there's the equation in symbol form: W equals m times g, weight equals mass times gravitational field strength. And then we'll describe how weight is measured and describe the relationship between the weight of a body and the gravitational field strength. And if you look at that equation, weight is proportional to gravitational field strength, so if the gravitational field strength doubled, the weight of the object would double. Learning outcomes: describe the difference between mass and weight, list the factors that determine the weight of an object, recall the equation for calculating weight, describe the difference between mass and weight, list the factors that determine the weight of an object, and finally, recall the equation for calculating weight. So they're the learning outcomes. And then after this week's completed, hopefully you'll be able to answer these questions, which are: what is the difference between mass and weight? What are the factors that determine the weight of an object? And how do you calculate weight? So I'll give a bit of a description now from for the learning outcomes to help you on your way. But then obviously there's the video lessons that are on Edpuzzle, any video resources I've put on the notebook, the PowerPoint within your notebook, and the textbook. Okay, so please make sure you look through all of these, and there's a video as well from the textbook. So the mass and weight topic, the learning outcomes discussed earlier. The first one was to describe the difference between mass and weight. So basically, if we have an object, we say that object, a physical property of that object, it has mass. But what does that actually mean? Well, if we think about the object will be made up of atoms. Okay, there we go. And the atoms have mass, so you can suggest the mass of the object is due to how many atoms and the mass of each of those atoms. However, if we probe a little further, what is an atom? We think an atom has a nucleus with protons and neutrons in, and then there are electrons orbiting around the outside of it. So there are subatomic particles, so then you could count up all the subatomic particles and the masses of the subatomic particles, and then the collection of all that gives the object its overall mass. There are actually particles that make up some of these subatomic particles. For instance, the protons and the neutrons are made up of quarks, and those quarks will have mass, and you add them all up and you get the overall object's mass. However, as we probe deeper and deeper, our understanding of what actually mass is, what is this physical quantity, gets a little vague. So although we have a good understanding of matter and atoms and subatomic particles, quarks, things like that, what we can say is that mass is just if we could just add up all this stuff, okay? And that's our definition. And it sounds kind of vague saying stuff, but what on earth is matter? Okay, so scientists, physicists are still trying to understand exactly what matter is and this property of mass. So it's just, we'll just say the amount of stuff. Okay, stuff an object has. Okay, so that's mass, and as it's a physical quantity we can measure, it has a unit. It's a scalar quantity, there's no direction to it, and the standard unit for that is the kilogram. Okay, so there's our definition of what mass is. Now weight, these can often be interchangeable, and it can get a little confusing, because often when we want to know how much mass we are made of, we often say, what's our weight? Okay, and this is because the weight is actually linked to how much force
So weight is a force, how much pull there is on you from the planet. Okay, and scales work in that way. If you stand on scales, the planet pulls you onto the scales, and the scales can tell you just how much you've been pushed on them, so that the scales push back. And then we often say we're weighing ourselves, but then we get an amount of mass in kilograms or stones if you're using imperial measurements. But really, the word weight means the force due to gravity. Okay, the pull of the planet on you or on the object. Okay, so they're the differences. Okay, and this is, as a force, it would be measured in newtons. Okay, so that's that first learning outcome. The second one, list the factors that determine the weight of an object. Okay, well, there is a link between these things. Mass and weight are proportional. It's an equation that was discussed at the start of the video. W for weight, little m for mass, G is the gravitational field strength. That's how much pull per unit mass. So depending on the size of the planet, the bigger the planet, the bigger the pull. The more mass something has, the larger the force between those masses. Okay, and so from this you can easily see that the weight of an object is directly proportional to its mass, and the weight of an object is directly proportional to the gravitational field strength. So if there is more mass, it would weigh more, or if it was on a larger planet with a larger gravitational field strength, it would have more weight. Okay, if you go on the moon, so on Earth, gravitational field strength is 10 newtons per kilogram, but on the moon it's about 6 of that, 1.6 and 1.7 newtons per kilogram. So even though you would be the same mass, okay, I meant the gravitational field strength, sorry, even though you were the same mass on the moon, you would be pulled to the moon with 1/6 of the force that you are on Earth. Okay, so they're the factors that determine weight. Recall, this is learning outcome 3, recall the equation for calculating weight. Well, there it is. Okay. Number 4 is describe the difference between mass and weight. Already done that. Okay, mass is just the amount of stuff, weight is a force due to gravity. Number 5, list the factors that determine the weight of an object, which is pretty much learning outcome 2, so I don't know why they've put that in twice. And then finally, recall the equation for weight. That is learning outcome 3 as well. Okay, so we've just repeated their learning outcomes. Okay, right, so that's pretty much the basics of mass and weight. And now if you go through all the resources that I've put out there, and then try the questions when they come out on Wednesday, and any time you're stuck, just ask me.